Yeah, when a math teacher says fun, it probably means challenging. And that would be correct today. So, Unit 3, Day 2, Day September 11th. All right, partial fraction decomposition. It even sounds weird. Like fractions alone makes some people scared. And now we're talking about partial fractions and decomposing them. Like, what in the world are we doing today? Well, let's back up. We know how to add rational functions. This was Friday's lesson, right? Just adding fractions with a common denominator. Right? This guy needs an x plus 2, top and bottom. This guy needs an x minus 3. And that's what this is shown, and then we distribute and combine, and no big deal. Or you guys all said it was no big deal because nobody had questions from Friday's worksheet. Today we're going to go backwards. We're going to start with the answer, and we want to figure out what two functions would have given us this answer. So that's the decompose part. We're going to take something that's already been made whole and decompose it into partial fractions. A very unofficial name for it is unadding fractions. All right, so we're not subtracting. It doesn't mean that. Someone has added two numbers together. What did they add to get there? And so we don't ever do this with numbers. It's like, okay, there's an 8. What numbers did you add to get there? I guess maybe you did that in like elementary school to just work on your math facts or something. But that's not something we really worry about. To undo something someone already did in order to break it into smaller pieces. And so a good question would be, why in the world are we doing this? Like, it's like we have the answer. Another way to phrase today is, it's a Jeopardy day. Right? Game show Jeopardy, where they give the answer and you have to give the question. That's what today is. Like, here's the answer. What was the question? And the reason we'd want to do that is more of a calculus answer. Like, this thing cannot be integrated. Confused face. This thing is pretty easily integrated. And so it's more of a calculus thing of when we need it. But this is PreCal, so we're building up those skills so that when we get to calculus, we'll be able to integrate this, not because we can integrate this, but because we can turn it into that using partial fraction decomposition. Okay, let's look at how to do this. Write the partial fraction decomposition of x plus 7 over x squared minus x minus 6. And you can see we have basically half a page to do this. So let's factor that first. So x minus 3, x plus 2. Okay, if we added fractions to get this as an answer, I think the easy part is I know what the denominators were. Right? The denominators would have been x minus 3 and x plus 2. That's the easy part. Yes, sir. Yeah. What I don't know was the numerators. I can tell by looking what the denominators were, but the numerators, I don't know. So I'm just going to call those A and B, and that sort of becomes the name of the game, is figuring out A and B. And later, if we have 3 terms, it'd be A, B, and C. If we had 4 factors, it'd be A, B, C, D. We're not going to get that far, and so on. Okay, well, this looks rough, ugly, terrible. Any of those words would work. We don't really like fractions. Is there something we could multiply by that would make all of the fractions go away? The common denominator. So let's multiply everybody by x minus 3 and x plus 2. Both sides. This will complicate some of the numerators, but get rid of all the denominators, so well worth it. Well worth it. On the left-hand side, what happens on the left-hand side when we multiply by x minus 3 and x plus 2?
It just becomes x plus.
Yeah, it all goes, well, all the denominators go away, and we're down to x plus 7. On the first term on the right, the x minus 3's cancel, and that leaves a times x plus 2. And for the second term, the opposite thing happens. The x plus 2's cancel, and that leaves x minus 3. I'm still trying to figure out what a and b are. And it's supposed to be true for all values of x. So at this point, I want to pick some good values for x. This will work for any values of x, but if I'm careful and smart on the values that I pick, I can make my life a little bit easier. And by saying smart and good, I would really like to make some stuff go away. So you got a good idea for what x could be to make some parts of that equation go away? 3 would be a great pick because it would wipe that whole term out. So let's let x equal 3. So n goes 3 for x. 3 plus 7 equals a times 3 plus 2 plus b times 3 minus 3. And of course, that was the whole point of picking 3, because it wiped out this term. And so 5a equals 10, a equals 2. Don't lose sight. The point of this problem is to figure out what a and b are. So we're halfway there. We got a. What else could we let x be? Negative 2, because that'll wipe out the other term. So let's let x be negative 2. So negative 2 plus 7 equals a times negative 2 plus 2 plus b times negative 2 minus 3. So that would be 5 equals, the a stuff goes away. That's why we picked x to be negative 2. That was one of our good values to use. And then b times negative 5. So b equals negative 1. Okay, so we're done with the math, but we still need to report our answer. Again, the Jeopardy comparison. I got to give my answer in the form of a question. The answer is not a equals 2 and b equals negative 1. The answer is, how can we decompose this original fraction? Make sure you put, you guys that are kicking yourself for dumb mistakes, here's a good one to avoid. Make sure you put the a over the a stuff and the b over the b stuff, right? You don't want to do all of this work and then just copy them down in the wrong spot. So a is 2. 2 over x minus 3 plus negative 1 over x plus 2, and that's my answer. And again, the point is, in calculus, it's hard to work with the original. It's a lot easier to work with the pieces. So we decomposed this whole fraction into some partial fractions. All right, now let's make things a little trickier here. Let's factor the bottom. So factor out an x, that leaves x squared plus 2x plus 1. And then x squared plus 2x plus 1 factors into x plus 1, x plus 1. So 3x squared plus 6 over x times x plus 1 squared. And again, we want to break that into pieces. So one of the pieces would definitely be over x. But that squared term, a repeated linear factor, right? The x plus 1 is a double factor, a double root. Any idea? Yeah, I don't know that you'd come up with this.
Square the fraction.
So if you think about what would be added to get that, you would definitely have to have an x plus 1 squared. Otherwise, where would that square come from? Right? Like there's no other. You wouldn't just put two of them down there unless you needed two of them down there. But the trick is, and here's the part you might not have come up with, is that you could also have had a fraction that was only over x plus 1, and you still would have had the same common denominator. So this extra term here is maybe the tricky one. Like clearly one of them would have had x plus 1 squared in order to get that for a common denominator. But you could have had one that only had one x plus 1 in the bottom. Does that make sense? So this is going to get a little bit trickier here in a minute. Yeah, and it may turn out that C is 0, and that might come out in the process. We just don't know yet. All right, again, let's multiply by the common denominator on both sides. So left side, super easy. Everything cancels. 3x squared plus 6. On the right side, well, the first term's easy. The x's go away, and that leaves x plus 1 squared. The second term, I think easy as well, right? The x plus 1 squared goes away, so I've got b times x. Third term, a little trickier. Yeah, one of the x plus 1s cancels, so I'm left with x and x plus 1. So I'm left with both factors. All right, let's pick some good values of x. So what would a good choice be?
-1.
-1 would be a great pick. I'm going to show maybe a few less steps this time. If I plug in -1, 3 plus 6 is 9, equals a times 0. That's why we picked -1. Plus b times -1, plus c times -1 times 0. So all that stuff cancels out, and I get b equals -9. I'm trying to start to save space here. If you hadn't figured that out. Okay, so what's another good value for x? 0 would be a great pick. So 3 squared plus 6 would be 6. A times 1 plus b times 0. And once you've done some of these, you start to, like, as soon as you see it's b times 0, you might not even write that because you know it goes away. Plus c times 0 times doesn't really matter after that because it's 0. So a equals 6. I need to figure out what c is, but I'm out of good values of x.
1.
Right? Like there's nothing else to make stuff go away. So at this point I have to just pick a value for x, and it's not going to make stuff go away, but I've got to have something. So you can pick whatever you like. You know, you can pick 17 or -43, but the math would probably be a whole lot easier if you pick something simple like 1. So it doesn't have to be 1, but I think that would be the easiest thing to pick. So let's see, 3 plus 6 is 9. And then this gets a little bit tricky because nothing goes away. a times 1 plus 1 squared is 4. B times 1 plus C times 1 times 2. I'd like to know C. I've got an A and a B stuck in there though.
When you plug in the values we found.
But I already know A and B, so I can plug those in. So 9 equals 4 times 6 plus negative 9 plus 2C. So let's see, add the 9, that's 18. Minus 24 is negative 6. So C equals negative 3. All right. The hard part's over, but again, Jeopardy, I still have to answer in the form of a question, give the answer in the right format. So A over X, again, just make sure you're careful on matching up your letters with the right fractions. So 6 over X plus negative 9 over X plus 1 squared plus negative 3 over X plus 1. Do you know how you check your answer to see if that's right?
Go back.
Yeah, add them up. So you need a common denominator. So this would need, just work the same problems from Friday, and you should get back to where we started. Not really recommended because that takes a long time, and we usually don't have that kind of extra time on test. But if for some reason you had an extra 30 seconds on a test and you really weren't sure about this kind of problem, there is a way to go backwards and see if you got where we started off. All right, type 3 here. Distinct linear and quadratic factors. So let's factor the bottom here. Factor out an x. That leaves x squared plus 4. But I can't factor x squared plus 4. So let's see how we handle this. There's only 2 factors, so it's a little bit like that first one, where the only things we could have added to get this denominator would be an x and an x squared plus 4. So in that sense, there's no repeated factors in the bottom, so it's a little easier on that front. But the numerator, a over x, that's easy. But you think about getting the numerator, it's possible that this numerator wasn't just a number. It could have been bx plus c. So 1 less degree than the denominator. Now, for us, it's always going to be the worst is going to be as a quadratic in the bottom. So it'll just be bx plus c in the top. If things got really crazy and you had a cubic down there, you would need a bx squared plus cx plus d in the top. And you'd have a really ugly thing to deal with. So for us, it's not going to get any worse than that, but there's the reasoning. Always 1 less degree in the top. All right. So from here, it's kind of the same as all the previous ones. Multiply by the common denominator on both sides. So we shouldn't have any denominators left. And then in this one, let's see, the x squareds go away, or excuse me, the x squared plus 4 goes away. So I've got bx squared plus cx. You start peeking ahead, you realize there's difficulty on our horizon. What's a good value of x? 0. Definitely a great one. So 4 equals a times 4 plus 0. I mean, I'll write it if you need to see it. B times 0 squared plus c times 0. So a equals 1. Okay, that was an easy one. What about another good value of x? Okay, well, the short answer is there's not another good value of x, right? Because if you put in negative 2 and you square negative 2, you get positive 4. So that doesn't help. Technically, the I stuff would work, but I don't want to plug in 2i and then I'm going to have i's and negatives. That's going to be a mess. Like, I think it would work. Nobody teaches it that way, so let's don't do that. Although, I suppose it should work, so do it if you want to. Let's just pick x equals 1 and see what happens. So 3 plus 4 would be 11 equals a times 5. Although we already know a, so we could make that swap there. Plus b plus c. So a is 1. So 6 equals b plus c. Well, okay. That doesn't... I mean, it's better looking than what we started with, but I don't know b or c yet. So let's pick another value of x and see what happens. I'm definitely out of really good values. Now I'm out of easy values. Now I've just got to pick something. 2, 3, negative 1. I don't know that I'd pick 3. I definitely would not pick 25. 25 would work, though. You just have big numbers to deal with. I'm going to go with 2, because I'd rather deal with 2 than negative 1. But if you don't mind working with negatives, maybe negative 1 would be better. It totally doesn't matter at this point. 3 times 4 is 12. 4 times 2 is 8. And then on the other side, a times 4 plus 4 is 8. Plus 4b plus 2c. So what does all of this become? A is 1. So if I subtract the 8 over, I get 16 equals 4b plus 2c. Thoughts? I could at least simplify this, right? I could make this a little bit easier. Divide everybody by 2 and get 8 equals 2b plus c. So now I've got 2 equations with 2 unknowns. System of equations. Like, oh yeah, we did that in Algebra 2. Never thought we'd need that again. B plus C equals 6. 2B plus C equals 8. And so here's where you've got those options of graphing, I suppose. We're not going to graph it. Substitution, not awful. But elimination or combination is probably the best way to go. Right? That's where you multiply one of them by negative 1 or negative whatever you need to make it work. So that would be negative b minus c equals negative 6. And then I can combine those two to get b equals 2. And then plug that back in and I get c equals 4. And so now I've got all my pieces. You hesitate to circle those because I'm not done. But that's what I was looking for, A, B, and C. So I've got all the pieces. So A over X, again, make sure you match up the pieces, right? 1 over X plus dx plus C. So that's 2x plus 4 over x squared plus 4. That one would be that one would be easier to check. I guess that's always true. Easier to check than to do the first time. Like multiply the first fraction by x squared plus 4 and the second fraction by x. You could almost check it in place there. X squared plus 4 plus 2x squared. Yep. Plus 4x. Yeah, that works. That one's not too bad to check. And given how difficult it was, maybe that's not a bad plan. All right, so let's do an example or two. Let's see. How many examples do we want to do? In 15 minutes. Tell you what, factor the denominators for all of those, and then we'll see which ones you think we should do. Do it that way. So you take a moment to factor all those denominators, and then maybe we'll set them all up and figure out what ones we need to do start to finish. So the first one, x plus 5, x minus 2 for the factors. Second one is a difference of cubes, so it starts with x minus 1. SOAP tells you the signs, same, opposite, always positive. Whoops, mine's not right. What's that? What am I missing? X squared. Square the first one, multiply the two together, square the second one. And then that last one is an easy factoring, but it's number 3 because it's a repeated factor. Okay, so you tell me. 1, 2, or 3? 2? Alright, so x over x cubed minus 1 equals a over x minus 1. That'd be the easy part. The second denominator is x squared plus x plus 1. What would the numerator need to be? Yeah, if the denominator is quadratic, the numerator needs to be linear, so bx plus c. Oh, I probably shouldn't have written it like this. It's not wrong, but it might have been a little easier if I'd written it in factored form.
Wait, why is it bx plus c again?
Your numerator is always one less degree than the denominator. So if you're stuck with a quadratic denominator, like it doesn't factor any further, then our numerator has to be linear.
So instead of having c off to the side like we did at one time, you include it? Or like, what makes the difference of having c off to the side and having 3 terms instead of adding c?
Because it would be the same denominator. Like if you wrote it as 3 separate terms but had the same denominator, that would be okay. Is that what you're saying? Like, why couldn't I just write this as 3 separate?
Mm-hmm.
You could.
It's just a lot more.
It's just more. It's not really more work. It's more writing. It's not wrong. It's more writing. So it's not really even more work. Not more thinking. It's more writing. But it would not be wrong. And in fact, I think that's what. So looking at these borrowed notes from a previous year. Like they set up that last one like that. But then this person on this one set it up like that. So it doesn't matter. Because they have a common denominator. Alright, so let's multiply everybody by x minus 1 and x squared plus x plus 1. X minus 1, x squared plus x plus 1. This is kind of a side note. I've tried to warn you guys about showing your work because many of you guys are great math students, which is fabulous, which means you're able to skip a lot of steps, which is great. But if you skip one more step than you should have, then you miss the problem because you were trying to skip steps. So skip steps is fine, but don't skip too many. Please be careful. And this is a great place to, slow down and show what you're doing. Not only so you can get partial credit, but so that you can kind of keep track of it yourself. Oh, that's kind of ugly. I don't know if I want to foil that yet or just leave that alone. I think I want to leave it alone for now. I may have to foil it eventually. So what do you want to pick for x? 1. In fact, yeah, speaking of not foiling it, let's pick x equals 1 and it would wipe all that out. And again, 1 plus 1 plus 1. I'm not going to show all that. That's 3. So 3a plus all that's 0, so it doesn't matter. Right? That's why we picked 1, to wipe all of this out. So a is 1/3. Well, lovely. You got a fraction to mess with. And I would say we are now out of good terms, good values of x to plug in, which is unfortunate because I have 2 values left. So I know already I'm going to end up with a system of equations here. So what do you suggest? Oh, we already used 1. Let's use 0. I hadn't used 0 yet. That should make things reasonable, I suppose. Actually, yeah, that'll wipe out the b term, so that's pretty good. So if I'm plugging in 0, I get 1a plus, let's see, the b term goes away, c times negative 1. Oh, I just thought I was going to have a system of equations, but the 0 wiped out the b, so I'm good there. So this means that I need to plug in 1/3.
It means C equals A.
Or it just means c equals a, either way. At some point, c equals 1/3, because c equals a. Or plug in 1/3 and move things around, and c equals 1/3 also. I hesitate to box these because they're not my final answer, but I don't want to lose them after I've worked all this stuff. I want to make them easy to find. So all that's left is b. What would you like? What value of x would you like to try? Yeah, I would say 2. You could do -1, but I think 2 is probably easier. So 2 equals, I'm going to go ahead and plug in 1/3 for a, because I'm going to need it. And then 4, this is me skipping steps because I'm short on space. 4 plus 2 plus 1 is 7. Plus 2b plus 1/3, yuck, times 1. So that wasn't as yuck as we thought it was going to be. Still yuck, just not as yuck. Degrees of yuckiness. So 2 equals 7/3 plus 2b plus 1/3. 7/3 plus 1/3 is 8/3. 2 minus 8/3. 6/3 minus 8/3 is -2/3. Should have wrote smaller from the get-go. So b is -1/3. Again, I'm not done with my answer until I put my answer in the form of a question. So a over x, and I don't mind the fractions in fractions, so I'm just going to put 1/3 over x minus 1 plus -1/3 x plus 1/3 over x squared plus x plus 1. Alright, do I need to maybe set up the other two just to make sure we're on the right path? Why don't you set up number 1? You don't have to work it because we don't have time. Set up number 1. Here. Did you set it up the same way as me, or did you set it up a little bit differently? a little different. The order doesn't matter, right, because you're adding, so it doesn't matter who you call A and who you call B. And we all factored this, if you followed my lead, you probably put it the other way, which is fine. The whole point of me doing this backwards is that if you're checking your work with somebody or you're working together and all you say is, hey, what'd you get for A? Well, maybe their A is different than your A, so be careful. You would need to say, hey, what did you get for the number over x minus 2? What did you get for the number over x plus 5? So be careful if you're working together and trying to check your work. Make sure you set it up the same way if you're going to compare answers. Do you remember how to set up number 3? So one of them is over x plus 1, and another one is over x plus 1 squared. And you can do those backwards. And again, so you'll have a different A and B, but you'll have the same final answer. So be careful if you're checking with each other on these. You can get confused if you're just saying, what'd you get for A, what'd you get for B? And then you're both looking for your mistake, and nobody made a mistake, you just set it up differently. All right, assignment is worksheet 2.